Hi guys, welcome back to Geometry Lessons with Miss B. Today we're going to be going over lesson 15.4, segment relationships in circles. Okay, so what it starts out with is it says, sometimes two chords drawn inside the same circle will intersect, causing four segments. So I'm going to highlight the four segments in different colors. So here's segment 1. Okay, here's segment 2. Go here, segment 3. And segment 4. Okay, so those are your four different segments. Okay, so these, we're going to go over some different theorems and properties that relate to these segments in this lesson. So the first theorem that we're going to go over is the chord-chord product theorem. This states that if two chords intersect inside a circle, then the products of the lengths of the segments of the chords are equal. Okay, so basically what this is saying is they're saying AE times EB equals CE times ED. Okay, so I'm going to highlight this. So we're going to get different colors. So we have AE. Okay, so AE right here. We have EB. So we have EB. We have light blue of DE or ED. And then we'll have the purple of CE. Okay? So what this is saying is that when you have these different chord lengths, if you can do the two halves of the one chord, if you multiply them together, they will equal the two halves of the other chord. So you can use these to find the different chord lengths. Okay, so we're going to go down, we're going to do some examples with this. So this first equation, or this first example, sorry, not equation, says find x and find the lengths of the chords. Okay, so we know the lengths of CE, BE, and DE, but we don't know the length of AE, okay? So I'm going to set up my example, or I'm going to set up my equation so that we can find AE, or find X. Okay, so I'm going to do CE times DE equals BE times AE, okay? So CE is equal to 6, DE is equal to 2, BE is equal to 3, and AE is X, because we don't know, okay? So 6 times 2 is 12, equals 3 times X, or 3X. We divide by 3, and X gives us 4, okay? So I go in and I plug in. So I already know the length of CD, because all I have to do is CD equals 6 plus 2, which gives me a value of 8. And BA, or AB, is now 4 plus 3, which gives us a value of 7. Okay, so X equals 4, and these are the values of our chord lengths. Okay, so here we have another example. This time they tell us the length of the entire AD, so right here, is equal to 12. Okay, so since they tell us that they only tell us the part, so they tell us AE. Okay, so they tell me AE plus DE equals 12. Okay, so I know AE, so I know 3 plus DE equals 12. So I'm minus 3, so DE equals 9. Okay, so now I can set up my equation to find X. All right, so I'm going to do 9 times 3 equals 14 times X. All right, so that's 27 equals 14x, divide by 14, and we get x is equal to 1.93. Okay, so in order to find the length of BC, I'm going to plug in, I'm going to do 14 plus 1.93, gives me a value of 15.93, and AD equals 12, since they already told us that at the beginning. So for the secant product theorem, this is saying that the entire part of the secant, which I'll highlight in a dark blue, okay, times the part of the secant, which will be in a light purple, so right here. So this is right here. This is AE, okay. So if you multiply the whole secant length, okay, times part of the secant length that's outside of the circle, and you set that equal to the full length of the other secant, multiply that by the partial length of the other secant. Okay, so that's DE, and this is CE. Okay, you can find the values of these different secants. Okay, so that's the secant theorem. And so it says that the full secant times part of the secant that's outside the circle equals the full secant of the other secant times part of the other secant. So I know that sounds a little confusing, but you're going to be able to see it when we go into these examples. So for this example, it wants us to use the secant-secant product theorem to find x and find the chord lengths. Okay, so since CA, which is, I will highlight in light green, so CA is the entire length, I would do it CB plus BA. So BA is 5 plus CB, which is x. So it'll be 5 plus x. So I'm going to do CA times BA is equal to EA. Okay, I'm going to highlight that one. So EA is the other one. Okay, I'm going to go back here. So times EA times DA. Okay, so CA is 5 plus x times BA, which is 5, equals EA, which is a value of, I forgot to put this as 6, okay? So EA is 6 plus 6, so it's 12 times DA, which is 6, okay? So I get, when I distribute this out, okay, I get 25 plus x is equal to 72. I minus 25, minus 25, and that gives me a value of, 5x plus 5x. 5x is equal to 47. Okay, so I divide by 5, and I get that x is equal to 9.4. Okay, so in order to find the length of CA, I'm going to do 9.4 plus 5 gives me a value of 14.4, and this is CA. Okay, so this is how you solve the first example. So here we have our second example, and we're going to do the same thing. So we're going to find the value of UP, which is right here, and we're going to use this value right here of PS to help us solve for that. So we're going to do SP times RP is equal to UP times TP. Right now, TP is very valuable in our society, so I had a little laugh when I first realized that it would be TP as our chord, so it just gave me a little bit of a laugh. I hope it makes you guys laugh as well. Okay, so going back to the math, SP, make that look more like a P here, okay, is 8 plus 6, okay, times 6, which is RP, equals UP, which our entire value is x plus 7, times a value of 7. So that gives me 14 times 6 is equal to 7x plus 49. When you multiply 14 times 6, that gives you a value of 84. So it gives 7x plus 49. We're going to subtract 49 from both sides to give us a value of 35 equals 7x. Divide by 7, and x is equal to 5. So I'm going to go back in and I'm going to plug in my x. So I get UP is equal to 5 plus 7, which is 12. Okay, and x equals 5. Okay, so that is how you use the secant-secant product theorem. So we have another theorem right here. This says the secant tangent product theorem. If a secant and a tangent intersect in the exterior of a circle, then the product of the lengths of the secant segment and its external segment equals the length of the tangent segment squared. Okay, so I know that's a lot of words, so I'm going to simplify this down. So AC is our entire segment, right? Okay. And so we're going to say that since this is the secant tangent theorem, we're going to say that this is actually, I forgot to put B here, okay? And B is its outside segment, okay? So this is BC, this is its outside segment. And here in hot pink is our tangent segment, okay? So this is saying that you can do the whole entire secant, so AC, times its outside segment, BC, is equal to the tangent segment DC squared. Okay, so that is what this is saying. So I'm going to highlight those so that you can correspond to them. So DC is our tangent segment. Okay, AC is our full secant, and BC is our secant segment that's outside the circle. Okay, so we're going to use this theorem down here in these examples. So this example says find x. Okay, so we're going to use our segment, our secant tangent product theorem. Okay, so this says that dB, which is our entire secant, times CB is equal to AB squared. Okay, so the value of dB is 2 plus x because we don't know what DC is. Okay, so times CB, which is 2, is equal to 5 squared. Okay, so I'm going to distribute my 2. So I'm going to get 4 plus 2x is equal to 25. Minus 4, 2x equals 21. When you divide by 2, x gives you 10.5. So my value of DC is equal to 10.5 plus 2, which gives me a value of 12.5. Okay? So that is how you use the secant tangent product theorem for that example. So here's another example. This one says to also find x here. Okay? So we're going to use this theorem, and it looks just like the theorem that we had up here. We're going to do the full length of the segment, so AC, times BC, the partial length of the segment that's outside the circle, and CD, which is our tangent segment. Okay? So we get AC, which is 6. So we're going to do AC times, not plus, times BC is equal to DC squared. All right, so AC is 6 plus 4, it's a 4, times 4 is equal to x squared. So 6 plus 4 is 10 times 4 equals x squared. And in order to get rid of a squared, you have to square root it. So I square root both sides, and I get the square root of 40 is equal to x. Okay, and when you square root 40, you get a value of 6.3. Okay, and so the segment value of DC, so DC equals 6.3. Okay, and that is how you use these theorems. If you guys have any questions, please feel free to reach out to me through Google Voice, email, or the Remind app.